Once again, very good day to everybody. This is Algorithms 1, and in this class, we discuss about the closest pair and then convex hull problems, and of course, the exhaustive search as well. So, this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So, before beginning the session, once again, let me thank God for giving me this opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. So in this class, we actually discuss with the divide and conquer algorithm. We discuss about the closest pair of points using this divide and conquer algorithm. How you sort, how you arrange the array strip, find the smallest distance, and then we have a divide and conquer program in the C++ to find the smallest distance from a given set of points. Then in the second part of today's class, we discuss about the convex hull using the divide and conquer, about the tangents between two convex polygons, and we have a divide and conquer program to find the convex hull of a given set of points. So I'll be giving you the independent work for you. Please complete them. As I'm reminding you, there are 10 independent works that has to be completed before the end of the semester. So at regular intervals, I'll be giving you some short videos to discuss the knowledge in our topics. So this is closest pair of points that you are going to exhibit using the divide and conquer algorithm, because we are going to identify n number of points in a particular plane, and your problem should be to identify the closest pair of points in the array. So in order to monitor these planes like x and y planes which are coming in, close together, okay, so there might be a possible collision and you have to find the distance between the 2 points. Do you remember the formula for the distance between 2 points? Do you remember the formula for finding what is the distance formula? No, what is the formula? No, you forget about this one, you tell. This is from the mathematics. Formula of finding two lines. For example, we have x1 comma y1 and then x2 comma y2. What is the distance between 2 points? What is the formula? It's a square times x1 square plus y2 minus y1 square, and all of them are square root. Exactly. This is the exact formula. Okay, x2 minus x1 the whole square plus y2 minus y1 the whole square, the whole you take root. So whenever you have to identify the distance or maybe the shortest path, then definitely you should go for the brute force approach with the case of order of n square, that is going to compute the distance between each of the pairs, and you are going to return the shortest path or maybe the shortened distance to it. Okay, so for this we will be calculating the smallest distance order of n log n using this divide and conquer strategy. So maybe let us take in the case we are trying to input an array of n points. Okay, the output should be the smallest distance. You are going to calculate the smallest distance between 2 points in the given array. Okay, so here the input array is first of all sorted according to the x coordinates. You have to find the middle point in the sorted array, and we have to take the point, okay, p of n by 2 as the middle point. Okay, so in this given array you are going to divide into 2 halves. First sub array will be having the points from 0 to n by 2, okay, and second sub array will be having n by 2 plus 1 to n minus 1. So we are going to divide this arrays. So you have to find the smallest distance in both the sub arrays, and the distance should be, for the left part it is dl and for the right part it is dr. So here the distance would be finding the minimum of dl and dr. So let us take in the case the minimum should be d. Okay, and from these steps you have to find the upper limit or maybe the upper bound d of the minimum distance. So here we have to consider the pairs such that one point in the pair is from the left half and other from the right half, and you have to join all the points. You have to join a vertical line passing through n by 2, okay, and find all the points whose x coordinate is closer than the d to the middle vertical line. Okay, so you have to build the array strip and you have to sort the array strip. Okay, so you have to go with the step. Okay, it is order of n log n, and you are going to go with the sorting and then merging all the points. Join all the outer points. Okay, so as to find maybe like polygon or maybe like a rectangle. You have to go with. Okay. So this is this one. So we'll have PL and PR, we'll have left and right. So you have to join the outer points. You have to find the minimum distance to the center, minimum distance from the right even, and you have to join them. Okay. So you have to find the smallest distance in the strip. Yeah, yeah. So it should be like order of n square step, that is actually required, but actually if you can see, if you can compute, it is order of n. Okay. So you have to find the minimum of d and you have to find the distance calculated from the above step. Okay. Right. So this is a divide and conquer program in C++ to find the smallest distance. So you have hash include bits slash std c++.h using namespace std function. So this is a structure to represent a point in the 2D plane. So class point, you are going to specify the public data type in x and y. So you are going to sort the array of points. So point p1 equal to point a, the p2 it is point b. So you are going to return p1 to x and p2 to x, and you are going to compare the const void a and const void b. Then point p1 is equal to point a, point p2 equal to point b. Okay. You are going to return p1y and then p2y. Okay. Then you have a utility function. Actually, the formula, whatever the formula we discussed in the beginning, that was what we are going to have. So float distance point p1 and point p2, return square root of, we had x1 minus x2 the whole square plus y1 minus y2 the whole square. So that you are going to mathematically compute. Okay, so p1x minus p2x multiplied by p1x minus p2x plus p1y minus p2y multiplied by p1y minus p2y. So whatever we mathematically computed, that we are going to return. Okay. Then we have the brute force method to return the smallest distance between 2 points. So float brute force point p in n, and float minimum, it is max value. So for int I equal to 0, I less than n plus plus I. Then within the loop, you will have the inner loop for int j equal to I plus 1, j less than n and plus plus j. So if this distance is less than minimum, means you are going to compute minimum equal to the distance of pi of pj and return the minimum function. Okay. And then you have a utility function to find the minimum distance between the two floating point values. So float minimum, float x and float y, return x less than y. You are going to compare x and y, and you are going to have a utility function. Okay, so this is the utility function to find the distance between the closest points. Okay, so you are going to have float strip closest, point strip in size and float d. So float minimum equal to d, that is you are going to calculate the minimum distance as d, and you are going to have the q sort strip size of that particular point, and you are going to compare. So you have the loop for int I equal to 0, I less than size plus plus I. For in j equal to I plus 1, j less than size, strip j of y minus strip I dot y less than minimum. So if this distance is less than minimum, so you are going to have the minimum equal to distance of strip I comma strip j, and you are going to return the minimum. Okay. Then you have the recursive function for the 2 or 3 points. You are going to employ the brute force approach. So if n is less than or equal to 3, you are going to return the brute force of p comma n, and you are going to find the middle point. So that is nothing but n divided by 2. Okay, so in mid equal to n divided by 2. Point midpoint equal to p of mid, and you are going to have the vertical line which is crossing that middle point. Okay, so float dl equal to closest point or maybe closest utility function p comma mid, and float dr is equal to closest utility function p plus mid and then n minus mid. Okay. Then you will have the smaller of the two distances, float d equal to minimum, the dl and then dr, and the point strip of function int n, j equal to 0, for int I equal to 0, I less than n, I plus plus. So if this abs p of I dot x is minus midpoint dot x, then you will compute strip of j equal to p of I, then j plus plus. Okay. Then same way you are going to return the minimum d comma strip closest, strip j and then d. So this is the main function to compute the smallest distance. So q's are p n and then size of the point, compare x. Then you have a recursive function. You return the closest utility function p of p comma n, and you have a driver code. Okay, so point p you will have 2 3 12 30 40 50 5 1 12, 10 and then 3, 4. You are going to have the n equal to size of p divided by size of p of 0. So that is what you are going to have, and output you are going to have the smallest distance, okay, and return 0. So this one, if you can see, the smallest distance you are going to compute, okay. So the time complexity would be T of n, and you are going to assume order of n log n. So here it is going to sort the strip and it is going to find the closest point in the strip in the order of n time. So the time complexity you are going to compute 2 T of n by 2 plus order of n plus order of n log n plus order of n. So this you can go with the computation of n and then log n the whole square, okay, or maybe order of n square, or maybe order of n multiplied by log n square, okay. So you can improvise the step, you can actually compute the smallest distance even, and also you can modify this algorithm with the case of merge sort or maybe heap sort also, right. This is very important, please all listen. This is very important, because everybody might get fear in understanding these steps, so listen to this one. So this is convex hull. It's actually a smallest convex polygon, okay, that would be containing all points. For example, if there are several points which are close together, you have to identify the polygon, okay, closest polygon for the given points, you have to join them, okay. Very easy, but sounds little bit difficult, okay. So this is convex hull. Let us take an example with the case of x and y coordinates. Input the points 0, 0, 0, 4, minus 4, 0, 5, 0, 0, 6, 0, minus 6 and 1, comma 0. Okay. How you get the output with the case of convex hull? First point is 0, comma 0. 0, comma 4. Yes. Third one, minus 4, comma 0. Yes. Then 5, comma 0. Okay. Then 0, comma minus 6. 0, comma minus 6. Yes. 1.0. 1, 0. Okay. You understood? Just join the points. That's all. Just join the points. Outer circle.
So then we got only these numbers and the remaining goes out.
See the output. Minus 4.
Yeah, I see the output.
5.
Minus 6.
0, comma minus 6.
And 4.
0, comma 4.
Yeah, that's correct. I got it.
With this basic, you will understand the remaining. This is what you saw here.
Yeah, I see.
Okay, so you have to first of all go through the tangents between two convex polygons, and from this only you are going to find the convex hull associated. Okay, so what you have to do, you have to merge these two convex hulls, maybe with the left points and the right points, left here and the right here, you have to merge them, and you have to determine the convex hull for the complete set. Okay, so this is what we are going to do, the upper as well as lower tangent. Okay, to the right and the left you are going to find them and you are going to merge them. Okay, so left convex hull be A and right convex hull be B. Okay, so left and up, the lower as well as upper tangents you are going to name it as 1 and 2. So this one, see the blue line, blue, this is the outer. Okay, irrespective of they form like this, they form like this, so you are just joining the outer. Okay, upper, lower, upper B, lower B. So this one you are going to go. So this is the divide and conquer program to find the convex hull for the given set of points. Fairly a very long program. Okay, so you are going to have using namespace STD function. You are going to store the center of polygon. Maybe at the end of the program, I will tell you once again. I will give you. Everybody, you try to join and find the output. But in the program, it's not. In the program, it is bit long, it is hard even. Okay. So here you are going to store the center of the polygon. First you are going to find the center point. So pair is less than in, which is greater than mid. Okay. So in quad, the pair is less than in greater than p. So if p first is greater than equal to 0 and p second is greater than equal to 0, you are going to have to return the points. Return 1, return 2 or return 3. Else case you go with return 4. Okay. You check whether the line is crossing the polygon. So in orientation, the pair is less than in greater than A, pair is less than in greater than B, pair less than in greater than C. Okay. So you find the resulting function B dot second minus A dot second multiplied by C dot first minus B dot first. So you are going to compute this one, and if this result is equal to 0, then return 0. Greater than 0 means you return 1. Otherwise you go with the return minus 1. And you compare the function for sorting. So Boolean compare pair is less than in greater than p1 less than in greater than q1. So you are going to have the pair with the case of this function in 1 equal to quad of p, in 2 equal to quad of q. So if 1 is not equal to 2, return 1 less than 2, and you return the p dot second multiplied by q dot first less than q dot second multiplied by p dot first. Then you find the upper tangent for the two polygons. Okay, so vector is less than pair. Okay, so the merger you're going to have. So n1 is nothing but the number of points in the polygon A, and n2 is nothing but the number of points in the polygon B. Okay, so n1 is equal to A dot size, n2 is equal to B dot size. So you have int ia equal to 0, ib equal to 0, you're going to initialize. Then you go with the for loop, int I equal to 1, I less than n1, I plus plus. So you are going to find whether it is lesser than the number of points in the polygon A. So if a dot I is dot first is greater than the a dot ia dot first, so you compute ia equal to I, okay, and you go with the leftmost point of the P. So for int I equal to 1, I less than n2, I plus plus, then you go with the loop. If b of I dot first is less than b of ib dot first, then ib equal to I, find the upper tangent. Okay, so int the function equal to ia and int b equal to indices b equal to ib. So boolean done equal to 0, while not done then done equal to 1, and with the case of while loop, orientation b of indices b, a of indices a of indices a plus 1. Okay, then the indices function plus 1 modulus n1. Then with the case of the orientation, while orientation of a of indices a, b of indices b, and you have n2 plus indices b plus 1, same like this one, minus 1 modulus n2. So you are going to compute this function, and you will go with the upper limit. Okay, int upper a equal to indices a, upper b equal to indices b, and you are going to have indices a equal to ia, indices b equal to ib. So done equal to 0. Then while not of done, so done equal to 1. So while the orientation, you will have this function in b is equal to in b plus 1 modulus n2. Then you will go with the while orientation of b in b, a in the end of a. So in a n1 plus in a minus 1 modulus n1. So for same for the upper part and the lower part, you are going to go with these functions. Okay. Then you'll go with the brute force algorithm to find the convex hull. Okay, so set pair, okay, it is less than int, okay, and greater than yes. So you are going to have the left and then right limit. For int I equal to 0, I less than a dot size, I plus plus, then the j loop, and x1 is equal to a I dot first, and then x2 is equal to a j dot first. Similarly, y1 second and then second. Okay. Then a1, you are going to find the distance y1 minus y2 and x2 minus x1, or maybe x1 minus x2. So this one you are going to find the distance. Okay, so x1 y2 minus y1 x2. So that you are going to find out, and you will have the k loop a1 dot ak dot first plus b1 ak dot second is less than or equal to 0. Similarly, the next loop, then you will go with the position, okay, equal to a dot size and the negative equal to a dot size. So s dot insert is equal to a of I and a of j. Then you go with the vectorization part with the mid first and then mid second, and you return the first and then second value. Then you try to sort the arrays. So for the entire point, you are going to find the convex hull. Okay, so if a dot size is less than or equal to 5, then you return the brute hull. Okay, so that is the outer point that you are going to consider, and you are going to find the convex hull for the left and right sides. Okay, so finally you will have this driver code. Okay, so this one I'm going to put it to you. Okay, so you have to find the convex hull of this given pair of point. Okay, so 0 0 1 comma minus 4 minus 1 comma minus 5 minus 5 comma 3 minus 3 comma minus 1 minus 1 comma minus 3 minus 2 comma minus 2 minus 1 comma minus 1 minus 2 comma minus 1 and 1 comma 1. So first of all, you are going to specify the size, you are going to sort it, and you are going to go with the divide and conquer approach. Okay. So the C out the convex hull. So for this one, you will have the printed E dot first and then E dot second. Okay. So my question to you, this one, can you find the convex hull of this given pair of points? Zero zero 1 minus 1. Yes.
1 minus 1
1
minus 1
here.
below here.
Okay, 1 minus 4. Minus 1 minus 5. This is minus 1. This is minus 5.
This is the this is the easy, but in program is hard.
Huh?
This is one easy. This is one is easy to find, but this one is hard to program.
That center point you have to take.
Yes.
Left, right, joining. That is hard.
Yes.
No, at least you understand the logic.
Yes.
With that you can. Yes. Minus 1, minus 5.
Minus 1 minus 5. Minus 5 minus 3. Minus 5 minus 3. Yeah. Just like that.
Okay.
Minus 3 minus 1.
Minus 3, minus 1.
Minus 1. Minus 3 minus 1. In below. Minus 1 minus like this. Minus 2 minus 2.
Minus 1, minus 3.
Minus 2 minus 2.
Okay.
Minus 2.
Minus 2, minus 2. Minus.
X is minus 2. Yes. Minus 1 also
বাচ্চারা 2 মিনিট কম্পিউটার মোবাইল করছে জয়দা 2 মিনিট কম্পিউটার বল একটা internet tu lagamos tá mexendo bom vai entrando bom outros anos
Minus 2, minus 1.
qual mais
minus 2 minus 2.
Here. Minus 1, 1. Minus 5, 3. Yes. Minus 1, minus 5. Yes. 1, minus 4. Yes. 0, 0. Yes. Minus 1. No, this is the outer.
This is the outer point.
Outer point.
This connects to the
Polygon. So with the case of time complexity, with the case of left as well as right convex hulls, it will be taking order of n time. So since we are dividing the two halves, your order would be n log n, and the auxiliary space it will be taking is order of n. Okay. So this is an independent work for you. It's a C++ program to demonstrate an application of exhaustive search.